So in the previous video, we looked at how each of those energy-yielding macronutrients go through the same three basic processes to get to our ATP that we can use for energy. Protein, glucose and carbohydrates, and then triglycerides. And the concept is that they have all these three basic processes. They get to acetyl-CoA, they go through the TCA cycle, they split the carbon-hydrogen bonds, that hydrogen is picked up by these carrier molecules, NAD, and brought through that electron transport chain, where we finally get carbon dioxide, water, and then ATP, that energy molecule in the body that we can now spend to sustain life and move our muscles and do what we need for energy in the body. But now let's take a look at that concept of what happens when we feast and when we fast. So the idea that we've consumed more calories than we need right now, or when we don't have enough. Now sometimes you look at this and you go, oh, if we have more of these energy-yielding nutrients, we'll get more ATP. It almost looks like a funnel where you can just pour things in and it magically pushes it all along till we get more ATP. But that isn't the case. Because if we have more ATP than we need right now, the body kind of slows all of these processes down and kind of shoves the pathways that will go to storing energy, which we already know. There's nothing real surprising about that, because we know when we eat more calories than what we need, we build energy stores or body fat. We actually have two types of energy store molecules on our bodies. We have glycogen, which is that storage form of glucose, and we can store that in two places, in our liver and in our muscles. We can also re-release that so that glycogen can go back to glucose. If it is glycogen in the muscle, it would only be used within that muscle. If it's in the liver, we can release that glucose from glycogen and put that into the blood, and now it can be used throughout the body. In particular, our brain. Our brain likes to use glucose for energy, and so that would be a great source of energy for glucose for the brain when we haven't eaten. So glycogen is a storage form of glucose. It's very limited. We don't have a lot of it on our body, probably only about 400 calories worth at any one time. So our major source of energy stores after we've feasted, which again we already know is body fat. We eat too many calories, we will build more body fat. And now we can sort of understand why. If we have acetyl-CoA as a central molecule in energy metabolism, everything gets there. We can look in that acetyl-CoA can be shunted over this way to produce more triglycerides, which is our fancy word for fat. So any of our energy-yielding nutrients, whether we eat it from our chicken, whether we get it from our potato with our starch, or whether we get it from olive oil and butter that we get in our fats, we can get it to this acetyl-CoA and put it back over here to body fat. And it does look like we take food fat and convert it right back into body fat. It doesn't happen exactly that way, but the bottom line is that we store more body fat. So the energy of feasting, we shift things over to acetyl-CoA and then shift it over to fats, and we store it as more calories that we can hopefully bring back out later and not just keep putting on more and more body fat. But we can understand how metabolically it happens. Now when it comes to fasting, it's a little bit more complicated. When it comes to fasting, we have to think about two key issues here. We need to have glucose. As I mentioned, that the brain likes to have glucose for energy and primarily only uses glucose for energy. And then we have to have body energy. And both of them are needed all the time. So we have to think about where we're going to get each one of those. When it comes to short-term fasting, so what I mean by short-term fasting, I'm talking about less than 24 hours. What will happen there is that we can get our source of glucose from glycogen. Remember, we've put glycogen into our liver when we had enough, and we could pull it back out and put it into the blood, and that would be our source of glucose when we haven't eaten. Let's say you didn't eat breakfast this morning and you need a source of glucose, that's where you're getting it. We have enough liver glycogen to sustain our brain and our blood glucose needs for about a day. Not quite, about 18 hours. But that's going to be enough for short-term fasting. Our energy at that same time will be coming from body fat, so that's not going to be really an issue throughout fasting. We are going to keep burning our body fat for energy, but we're always needing to be concerned about that glucose. Short term, we're going to use glycogen, and then our energy is going to be coming from body fat. Let's go on though. Let's say that you didn't eat for more than just a day. It's now been 2 days, and your glycogen now is no longer available. you've used it all. So we still have to have glucose. Your brain still wants glucose for energy, and we have to figure out a way to get glucose from other molecules. So we look at these pathways and go, well, which one of them can give us glucose? And here's where we are. We can see pyruvate can go back up to produce glucose. Now, we could get it from glucose to produce glucose, but that's not happening. If we're fasting, we haven't eaten any, and we've used all our glycogen, so glucose is not going to be a source of itself. So another way would come over here. Look at glycerol, the backbone of triglycerides. 3 carbons go to pyruvate, can go back up to glucose. And it will meet some of our glucose needs when we haven't eaten for a couple days. But if you look at it, glycerol is only about 3% of the whole triglyceride molecule. For every 3 carbons here, half of a glucose molecule, we're going to get 3 fatty acids, and we're going to get inundated with acetyl-CoA. We will use that for body energy, but it's an imbalance, and we just really is not going to be a good source of glucose. So fat, body fat, food fat, is not a good source of blood glucose. So our other source here is going to be amino acids. And about half of them are converted to a pyruvate before it would go down through the energy pathways. And so we can take that now and convert it to glucose. And this is what will happen. After about 2 days of fasting, of not eating anything, you've used your glycogen, we are going to use primarily body protein to be converted to glucose. So as weird as that may sound, we are using lean body mass to feed the brain glucose. We're using the amount of body protein at a rate, after 2 or 3 days of fasting, you are using this at such a rate that if nothing happened metabolically, you would probably die in about 2 weeks. You're just burning through your lean body mass so quickly that you would die with a lot of body fat still on your body because you were just burning through lean body mass. So this is not a great way to get glucose. But it is our only pathway at this point to do. So very short term, our source of glucose is going to be glycogen. Intermediate short term, 2 or 3 days, it's going to be primarily body protein. Now if we go longer, let's go on for a week now, we have a major metabolic process that happens that will convert or shift the metabolic pathways. And the biggest thing that will happen, it will drop its glucose needs. So how do we do that? What happens when you start pulling out all this triglycerides, and we're going to pull this glycerol over to glucose, what little is there would be used to produce glucose. We get inundated with acetyl-CoA, and this starts building up. Now if we build it up when we're feasting, we just put it over here to fat. But it's not metabolically happening. We're breaking it down. This is building up. TCA cycle, you cannot force that to go faster than what you need. So it goes at the pace of energy that you need. It won't go faster. Building up, no place to go. And what happens is the body shunts this over to produce ketones. So ketones is a fat-based molecule. We can get this from fat. And what happens is the brain starts using ketones for energy. You've probably heard of the word ketosis. Ketosis is the condition of having ketones in your blood. And when you get ketosis, your brain can start using ketones for energy rather than glucose. So your need for glucose drops. And we still are going to be using protein to produce glucose, but the amount that we need drops dramatically. And because of this one shift, the shifting over of producing ketones and the brain start using it, we can now live about 2 months without eating rather than just 2 weeks. It is a major adaptation to long-term fasting. So 3 phases. Very short term, we can use glycogen for our source of glucose. The intermediate phase or short-term, longer fasting, 2 or 3 days, we're going to use primarily protein to produce that glucose. We will continue to use that in a long-term fasting, still going to be a source of glucose, but our need for glucose drops dramatically because the body starts producing ketones from a fat-based molecule, and the brain can start using this for energy rather than having glucose. Now, I mentioned already long-term fasting, that would happen, but any time you have a limitation of glucose, this process will go on. So this would occur with just being on the low carbohydrate diet, the Atkins diets, and those really, really low carbohydrate diets. You're doing essentially the same thing as fasting. You're not giving those cells glucose that you need. So the body will shift this over, and a lot of those types of diets will actually have you test your urine, because a little bit of this will go in your urine, and we can see if you are in ketosis. So we have long-term fasting without eating, long-term very low carbohydrate diets, and the other instance where this will occur when you have uncontrolled diabetics, because this is all happening inside a cell. Every cell has a mechanism to do this, and with diabetes you cannot get glucose inside the cell. So we have a lot of glucose in the blood, but if we can't get it inside the cell while these processes are going on, it's as if it wasn't there. So these same processes will go on until the diabetic starts taking medication to help get that glucose inside that cell. So fasting, we always have to worry about glucose, and energy we're going to get from our triglycerides.